morning guys. So this is the continuation of experiment number 7, mechanical waves. So this is about longitudinal wave, and then as what I told you a while ago, one of the examples of the longitudinal wave is the sound wave. Okay, so in this experiment we will be identifying the velocity or speed and wavelength of sound wave. Okay, we'll be using also the sine wave generator, and the sine wave generator is connected to the open speaker, and then this is called the economy resonance tube. Okay, so what we will do today is we're going to compare the theoretical volume and experimental volume of the sound wave, speed of sound wave, and the theoretical value will be based on the room temperature. Okay, so the room temperature of course this room is measured using the thermometer. Okay, so we have the formula to get the the theoretical value of the speed of sound wave. Okay, the formula is on your manual. So speed of sound wave is equal to 331.45 meter per second plus 0.61 multiplied by the temperature of the room. Okay, so meaning if the temperature of the room is 26 degrees Celsius, what you need to do is just use the formula which that is 331.45 meter per second plus 0.61 multiplied by temperature which is 26 degree. So whatever be the answer, so that is the speed of sound wave. So that's the theoretical volume, and then the experimental volume can be computed using the formula wavelength multiplied by frequency, and then again the frequency can be set here using the sine wave generator. Tapos wavelength can be computed using the formula na nasa manual din. So the formula for the wavelength is 4 multiplied by L plus 0.25 D diameter. Okay, so meaning we need to get the length of the air column or the resonating length. We need also to get the diameter of the inner tube. Okay, so the diameter of the inner tube is, so this is the inner tube. So this is equal to 14.5. Okay, so that's 14.5 centimeters. So diameter of the tube. So diameter of tube is constant. So that's 14.5 centimeter. Kailangan natin ay meter. So 0.145 meter. So constant lang naman yung diameter ng tube. Okay, yung length of air column nakadepende dito sa isaset natin na frequency. Of course, iba't ibang frequency, iba't iba yung kanyang resonating length. Okay, so we need to identify that. Okay, wavelength of sound ay we're going to use the formula, and then room temperature. So tingnan natin yung room temperature. Okay, so I think the room temperature is, so this is 20, 22, 24, 26. So 26 degrees Celsius. So that's the room temperature. Okay, so room temperature is 26 degrees Celsius. Constant din yung ating room temperature. Okay, so ang gagawin nating sunod is magsasa tayo ng frequency. Okay, yung frequency, bahala na kayo kung ano yung gusto nyo iset na frequency. Pero in my case, I will be setting this to 100 Hz and then 120 Hz. Okay, anyway, again, any frequency pwede kayo mag-set yan. Okay, and now the target is to identify the length of air column that will give the loudest sound. Okay, so mamaya, pag inaw natin yung sine wave generator, magkakaroon ng resonance in which maririnig natin yung sound niya. Okay, calling yung loudest sound, i-adjust natin yung length ng air column, this one. Okay, so kung mapapansin nyo, ito ay close. Okay, so what we will do is we're going to measure the length of this column. Okay, kung gaano siya kalalim, like that. So this is the length of our column. So paano natin i-measure yan? So that can be measured here. Okay, sa close. Okay, meaning guys, at this point, the length of our column is 17. Kung i-adjust natin yan, dito natin mababasa yung length ng air column. So ang gagawin natin is magsaset tayo ng frequency, tapos hanapin natin yung length ng air column that will give the loudest sound. Okay, kung saan tutunog ng pinakamalakas, that is the length of air column na kailangan natin mahanap. Okay, so on ko yung sine wave generator, nasa 100 na siya. So the frequency is 100 Hz. Okay, at yung nilagay ko doon sa manual, so frequency is 100 Hz. Ngayon, what I will do is, I will adjust the length of air column and then kikinggan ko kung alin or kung anong length ng air column ang magbibigay ng pinakamalakas na sound. Okay, so this is 39, 40, 51, lumalakas pa rin siya. Lumalakas pa rin yung sound. This is on 76 na, pero lumalakas pa rin yung sound. 83, 91, humihina na siya. So, since humihina na siya, ibabalik ko. Hanapin ko yung loudest. Eto, mukhang nandito yung loudest sound. Okay, so the loudest sound here is at 84. Okay, so yung length ng air column is 84. Okay, so nakita ko na yung length ng air column. So again, length of air column is 84 centimeters, so that is equal to 0.84 meter. Okay, so compute natin yung wavelength. Okay, we have now i-off ko muna yung sine wave generator. Okay, we have this first data. Okay, we have frequency which is 100 Hz, diameter ng tube is 0.145 meter, ito yung na-measure natin kanina. Yung length ng air column is 84 centimeters kanina. Okay, convert lang natin into meter kaya naging 0.84 meter. Okay, and then yung room temperature is 26 degrees Celsius, ito yung na-measure using the room thermometer. Okay, so I will be computing for the wavelength of sound dito sa frequency na 100 Hz. Okay, so wavelength is equal to, this is the formula, L plus 0.25 multiplied by diameter. Okay, so that is 4 multiplied by length. This is the length of our column, which is 0.84 meter. So 0.84 meter plus 0.25 multiplied by diameter na 0.145 meter. Okay, so this is equal to 4 multiplied by 0.84 plus 0.25 times 0.145. So the answer is 3.505. So this is 3.505 meter. So I'll be writing here the wavelength 3.505 meter. Or so now this is in meter. So correction, this should be in meter. Okay, so 3.505 meter. Okay, now what I will do is I will be computing for the experimental value of the speed of sound and the calculated speed of sound. Okay, unahin ko muna yung calculated speed of sound. So calculated speed of sound, the calculated or theoretical value, so this is the theoretical value. So the theoretical value is equal to 331.45 meter per second plus 0.61 multiplied by the temperature. So yung temperature is 26 plus 0.61 multiplied by 26 degrees Celsius. Okay, so the answer is 331.45 plus 0.61 multiplied by temperature. So this is equal to 347.31. 347.31. Okay, tulad na sabi ko, constant lang naman yung temperature ng room. So ibig sabihin, constant din lang yung value ng speed of sound. So this is 347.31 meter per second. This is also 347.31 meter per second. Ngayon, i-compare natin dito sa experimental value. Yung experimental value, yung formula is wavelength multiplied by frequency. Yung wavelength, ito yung kinompute natin using the formula na 4 multiplied by L plus 0.25D. So this is 3.505 meter multiplied by frequency na 100 Hertz. Okay, so this is 3.505 multiplied by 100. So the answer is 350.5. So this is 350.5 meter per second. Okay, compute natin yung percent error. Again, the target is below 10. Okay, minus 347.31 divide by, so this is the theoretical value, 347.31. Okay, multiplied by 100%. So the answer is 0.91. Almost zero na. Kunti lang yung ating percent error. So this is 0.92%. Okay? So that is for the first trial or frequency which is 100 Hz. Ngayon, check natin what is the length ng air column kapag 120 Hz siya. Okay, iwan ko siya and then change ko lang to ng 120. Okay, and then the same process, i-adjust ko yung length ng air column. Mag-start ako here. Unti-unti ko lang siyang i-adjust. Hanapin ko yung length ng air column na magbibigay ng pinakamalakas na sound. Tumataas pa rin siya, lumalakas pa rin. Humihina na siya. So, humihina na siya, balik ako. 70. Lumalakas. Okay. Actually, yung challenge dito is hanapin yung tamang length ng air column. So, ang gagawin nyo lang is i-adjust lang itong resonance tube. Okay. I think yung pinakamalakas is at 67 centimeters na length ng air column. Okay. So, 67. That's the length of air column. So frequency is 120 Hz, and length of air column is 67. So 67 centimeters is 0.67 meter. Okay, compute uli natin yung wavelength. Okay, using this formula, the same formula. Okay, so wavelength is equal to, anyway, so this is 350.5 meter per second. Okay, this is for 100 Hz. Okay, so 120 Hz, 4 times 0.67 plus 0.25 multiplied by 0.145 meter. Okay, so wavelength is so this is 2.825 meter. So this one is 2.825 meter. Okay, I will multiply the two. So wavelength multiplied by frequency, that is the value of the experimental speed of sound. Okay, so 120 multiplied by frequency times wavelength. So 120 Hz. Frequency or wavelength, ang wavelength is 2.825 meter. Okay, frequency is, or the wave speed is 339. So it's 339.0. Exacto siyang 339 meter per second. Now let's compute for the percent error. 339 minus 347.31 divide by the calculated value, 347.31. Okay, so times 100, so the answer is 2.39. So medyo mas mataas yung percent error niya, pero below 10% pa rin naman siya. Okay? So we have this is the table for the speed of transverse wave, and then this is for the speed of longitudinal weight. Okay, so this will be the end of experiment number 7. So, and then this is also the last experiment for midterm period. So let's just pray and hope na pagdating ng final period, matapos na yung crisis na to. So, para makapag-klase na tayo, hindi na makancel yung mga classes. Okay guys, so ingat sa bahay, huwag gala ng gala, and enjoy your online classes.